this problem, we're asked to solve by factoring this polynomial equation that's given here and to give all the real number solutions. So first I'd like you to notice that there may be a greatest common factor of each of these terms that could be factored out before trying to do any other methods of factoring you've learned. The first thing, see if there is a greatest common factor. Now, the greatest common factor would be something that would divide evenly into all of the terms. And remember, terms are separated by plus and minus signs. So this is a term, this is a term, and this is a term. We have 3 terms. And if I can think of the largest possible thing that would divide each of those evenly, then I will have discovered my greatest common factor, my GCF. So I'm going to notice that each of these terms has a number, a coefficient, that is divisible by 4. In fact, negative 4. So you always want to pull out negatives when you can. So part of my GCF is going to be negative 4. And then also you want to look at the variables. And then also you want to look at the variables to determine if there's what the highest power of variable would divide evenly into every term. So notice that every single term has at least one power of x. So that would mean that x to the power of 1 is part of my GCF. Now let's take this GCF and we're going to take each of these terms and divide by the GCF to see what we have left over. So that gives me x squared. Then this term, negative 4x squared divided by negative 4x leaves just x. And then this term, positive 8x, when divided by negative 4x, leaves just negative 2. So now I know that when I factor out, so if I take my original equation like this and rewrite it with the GCF factored out, then I will take the negative 4x out and put the remaining parts of each term into this set of parentheses. So I'll have x squared here, then x, positive x, then negative 2. Okay, so now I have partially factored my polynomial there on the left. And I want to continue to factor it if I can. And this is a quadratic polynomial with a lead coefficient of 1. So that means that I can hopefully factor this trinomial into 2 binomials. So since there's a lead coefficient of 1, I know each of my binomials will start with just x. And then looking at the last term, I have a negative 2, and 2 is prime. I know I'm going to have opposite signs because I have a negative number. So I need a negative number and a positive number to multiply to give me negative 2. And since 2 is prime, it can only be 1 and 2. So I know it's going to be either 1 here and 2 here, or possibly 2 here and 1 here. So how do we decide which way it should go? Well, we look at the middle term's sign, and since it's positive here, that means the larger value has to go with the positive. So this is the correct, right here, this is the correct way to write it, like that. Now we're going to use the zero product property, which is just a fact, something that's true, and it helps us know what to do next. What we know is true is that whenever you multiply something, some items together, some factors together, if you get a product, a result of 0, then at least one of the factors must be 0. So I'm going to take each one of my factors and set them equal to 0, and that will help me figure out what the value of x should be in order to make the original equation true. So I'm going to set negative 4x, that's one factor. I'll set that equal to 0 and then solve it for x. I'll also set the factor x minus 1 equal to 0 and solve for x, and the factor x plus 2 equal to 0 and solve for x. So now we just use inverse operations on each one of these equations until x is all by itself. So for the first factor, negative 4x equals 0, I'm going to divide negative 4 on both sides because the opposite of multiplying negative 4 times x is to divide negative 4. And as long as I do the same thing on both sides of the equal sign, it all stays equivalent. So here I am dividing negative 4 on each side. And since I know that 0 divided by anything is going to be 0, then my answer for this part is x equals 0. For the second factor, x minus 1 equals 0, I'm going to add 1 to both sides so that I get x equals positive 1. And for the last one, I'm going to subtract 2 from both sides of the equal sign to get x equals negative 2. So those are my solutions. X equals 0, x equals 1, and x equals negative 2 should all make my original equation true. And you should try each one of them before you submit your answers. Go back in and replace the x with each value individually, one at a time. So I might start by checking this one first. And just imagine if I changed all my x's to zeros. Negative 4 times 0 cubed minus 4 times 0 squared plus 8 times 0. What is that going to give me? Well, 0 cubed is 0, and 0 times negative 4 is 0, so that's going to go away. Negative 4 times 0 squared is going to be 0, and 8 times 0 is also going to be 0. So the whole left side turns out to be 0. So I get 0 equals 0, which is true, right? And so you'd want to do that also for the x equals 1 and also for the x equals negative 2 so that you'd be confident that your answer is correct. Okay, so quick recap. Find the greatest common factor, factor it out. If you have a resulting quadratic polynomial, that means that the highest power of x is 2. Then see if you can factor that out. And once you get down to powers of x that all the powers of x are just 1, then you can set each one of those equal to 0 to get your set of solutions.